to have a brief introduction to probability. I teach a semester-long course in probability theory, and we're not going to try to reproduce it in this one lecture, but we need to know a little bit about probability in order to do statistics. Why? Well, let's consider this question. A catalog company wants to know which catalog design, A or B, will make them the most money, and they want to know this before they choose one to send to 1 million customers. So they send design A out to 1,000 randomly chosen customers and design B to another randomly chosen 1,000 customers. So they're doing an experiment, randomized experiment. Here's the results they get. In design A, 117 people actually made purchases. Design B, 112 made purchases. And the purchases from design A, well, $95 was the average amount they purchased compared to design B, $87. So in the sample, A outperformed B. But maybe that was just coincidence. We're talking about a couple hundred customers out of the million that they have, and even the ones chosen for this experiment were only 1,000 for each design. So what does this really mean? Maybe it was just random variation. And design A may cost more to produce, so they don't want to do it unless they're sure it's going to make more money. So the way they decide is they ask themselves a question. If design A wouldn't outperform design B in the whole population of their million customers, how likely would it be? What's the probability of getting the data they just got? If design A is no better than design B, how surprising would this data be? And we'll see this argument a lot over the remainder of the course, but that's just a first hint, why we need probability. Many of our decisions in statistics are based on probability. So let's begin. Much of what you know about probability is already true. It quantifies the likelihood of an outcome of a random event. It gives the long-term proportion of that outcome when or if the event is repeated. If you roll a die, the probability of rolling a 6 is 1/6. So there's a huge surprise. Die has 6 sides, only one of them has a 6 on it, so there's a 1 in 6 chance. Now this doesn't mean that if you roll the die 12 times you have to get 6 exactly twice. It doesn't mean that if you roll it 18 times you have to get a 6 exactly 3 times. But what it does mean is that as you roll it more and more times, the proportion of rolls that came up 6 is getting closer and closer to 1/6. So there's some notation that we use in probability theory. P parentheses A is pronounced P of A, or probability of A. It's the probability that A happened. P of A with that little c, that means complement. That's the probability that A does not happen. P of A union B is the probability that A or B happens. P of A, B, or P of A intersect B is the probability that A and B both happen. And I'll usually just use informal language. P of not A, P of A or B, P of A and B, in place of those that the mathematicians use more formally. So, important laws of probability. Probability is always a number between 0 and 1. Nothing can happen more than 100% of the time or less than 0% of the time. So probability of an event is a number between 0 and 1. The probability that something doesn't happen is 1 minus the probability that it does. You knew that already. If you hear that there's a 20% chance that it rains tomorrow, then you know there's an 80% chance that it doesn't rain. The probability of A or B is the probability of A plus the probability of B, but only in special circumstances, if A and B are what's called disjoint or mutually exclusive, where they can't both happen. So if there's a 20% chance that I wear a red shirt tomorrow and a 30% chance that I wear a blue shirt tomorrow, then there's a 50% chance that my shirt is red or blue. P of A and B is equal to P of A times P of B if A and B are independent of each other, basically have no effect on each other. And we'll see examples that help make these clear, and later we'll look at the more general rules. So here's an example. A spinner comes up, gives you a number from 1 to 10. It's like a spinner in a children's game, and each outcome is equally likely. In a certain game you win if you spin a multiple of 3, 3, 6, or 9. Find the probability that you win, the probability that you lose, the probability that you win on 5 consecutive spins, the probability that you lose at least once in 5 consecutive spins. So why don't you think about these and see if you can answer them before going on to the next slide. Just go ahead and pause the video. So the probability you win is 3 in 10. There's 3 ways of winning. You get a 3 or a 6 or a 9. Each one of those has probability 1/10. So we use the OR rule and just add them together, or just look at the spinner. There's 3 ways of winning out of 10. Probability of losing, there's 7 ways of losing out of 10, which is 1 minus the 0.3. Probability that you lose is the probability that you don't win. So the probability that something doesn't happen is 1 minus the probability that it does. Probability to win on 5 consecutive spins. Well, each spin has a 30% or 0.3 chance of happening. Each spin is independent of the others. When you spin it the 5th time, it doesn't know what happened the other 4 times, so you get to multiply their probabilities. 30% of the time you win on the first spin, and then 30% of those you also win on the second spin, and 30% of those you win on the third spin. And that's why you multiply the 5 spins. The probability that you lose at least once in 5 consecutive spins, well, that's 1 minus the probability that you won on all 5. So 1 minus the 0.002, and that's the 0.998. At a certain large university, 30% of the students taking statistics get a grade of A. You choose 5 students at random. What is the probability that at least one of them you did not get an A? Well, that's the same as in the last problem. 1 minus 0.3 to the 5th, or 0.998. And let's save next steps for the next video.